Hello, today we are going to learn the recurrence formulas or recurrence relations. As we know in the last lecture, what is meant by the Bessels equation and the solution for the Bessels equation. So we'll just refer the solution of the Bessels equation and then we'll derive the formulas. The formulas for the recurrence formula, or you can say a recurrence solution. So let me write the general solution for the Bessels equation first. Now the Bessels functions, as we know, they are being denoted by j to the base n into x. Okay. Now the solution of Bessels equation is, so we are having solution of the Bessels equation is j to the base minus n into x, which is equals to summation of r equals to 0 to infinity minus 1 raised to r divided by r factorial open bracket minus n plus r plus 1 close bracket x divided by 2 minus n plus 2r. Okay, this is the solution of the Bessels equation. So now we are going to start the derivations for the recurrence formulas. So recurrence formulae, you can call them as recurrence relations also. So we are going to start with formula 1. So formula 1, and we will derive how these formulas we are getting it. So formula 1, it's x j, this one j to the base n, that is x dash x j dash n is equals to n jn minus x j to the base n plus 1. So this is a formula, the recurrence first formula, formula number 1. Okay, so we have to prove this formula. So as we know, what we know that the Jn, that is Bessel's function. Okay, now when Bessel's function, that is j of n, is equals to summation of r is equals to 0 to infinity minus 1 raised to r divided by r factorial, then n plus r plus 1 into x divided by 2 whole n plus 2r. Now you will find here in this case my base is n, so my n term is positive everywhere. Here my base n is negative, so everywhere the n term is negative. So this is only difference we are getting it here and here. Okay. Now differentiating this whole equation with respect to x. So differentiating with respect to x, we get j n, n is to the base j n dash is equals to summation of same r is equals to 0 to infinity. So we are having minus 1 raised to r, then this term n plus 2r, this will be with respect to r, so this will be differentiating, rest this will be constant. So yeah, n plus 2r divided by n factorial n plus r plus 1 into x by 2, here n plus 2r minus 1 into 1 upon 2. Okay, now what we will do is we will separate this n plus 2r separately. So we will have n divided by these terms and then 2r divided by these terms. Okay, so see what we are getting it as. I am taking this as x j n dash. So multiplying it with x also this side. So multiplying this side with x, this side with x. So what we are getting it as this n term. Okay, first I'll write the n term. N summation of minus 1 raised to r divided by r factorial n plus r plus 1 into x divided by 2 raised to n plus 2r. Okay, so this side also we had x, but this here it will be x, and here it was minus 1. See, here it was minus 1, so this minus 1 and that plus x got cancelled, so that's the reason we are getting it as only n plus 2r. Okay, n plus 2r plus the x summation of again minus 1 raised to r divided by r factorial. Okay, r factorial to n plus r plus 1. This will be into 2, then into 2, and we had some term called as 2r, and again x by 2 raised to n plus 2r minus 1. Okay, so as we know, this whole term is this, so we will substitute simply this as jn. So it will be x jn dash is equals to, this will be n jn plus x summation of r is equals to 1 to infinity. We are writing it as 1 to infinity minus 1 raised to r divided by r minus 1 factorial. Now we are substituting the value of for r in the later step. So before that we just need some substitutions here. So here I am substituting as r minus 1, and here it will be n plus r plus 1 into x raised to x divided by 2, here x divided by 2 n plus 2r minus 1. Okay, now again this term jn plus x summation of s is equals to 0 to n, so z is equals to 0 to infinity. So here in this substitution, let r minus 1 is equals to s. So we have considered r minus 1 is equals to x, so we are getting it this term. Okay, so here minus 1 raised to, so here it will be r, so it's simply r, so we need to write it as s plus 1, because this r is here, so this plus 1 will goes there, so it will be minus 1 goes there, so it will be plus 1. So next is s factorial, then it will be n plus s plus 1 plus 1 into x divided by 2, which is equals to n plus s, so which is equals to s plus 1 minus 1. So we are getting it as n jn plus x summation of s is equals to 0 to infinity minus 1 raised to s plus 1 divided by s factorial. Then this is 1 plus 1 2, so n plus s plus 2. Again upside also we are having some terms, so x divided by 2, which is equals to n plus 2s plus 1. Okay, so here in this part this 2 was there, s plus 1 was there, so 2s plus 2 plus 2, it was 2 and minus 1, so it becomes 1. Okay, now in the next step, so next step is just the last solution, that is njn. If you will see here in this part, we are having the values of this equation is almost same like this equation. So what we will do, we'll just separate this terms and see how it works out. Plus x summation of s is equals to 0 to infinity minus s minus s plus 1 divided by s factorial, and here in this part n plus 1 separate term plus s plus 1 separate term into x divided by 2, and that is equals to n plus 1. N plus 1 will write it together, plus 2s, so n plus 1 plus 2s. Okay, so as a result, if you will compare this equation with this, so you will get something as n plus 1 here, some s plus 1, and here also n plus 1 plus 2s. So same with this equation, and this equation is same, only the values are n plus 1 and here it is n plus 1 and n plus 1 and 2s, same way. So as a result, what we are getting this solution as the njn plus xjn plus 1. So as a result, x jn plus 1. So this is my first relation. Recurrence first formula or recurrence first relation. Now we'll start with the second relation for the recurrence. So we call it as a formula 2, or same way. Now, so it is xjn dash is equals to minus njn plus xjn minus 1. So proof. So we have jn is equals to summation of r is equals to 0 to infinity minus 1 raised to r factorial n plus 1 n plus r into x divided by 2 raised to n plus 2r. Okay, now again same thing, differentiating with respect to, so everywhere mostly for all the formulas we need to differentiate with respect to x, or we for further formulas we will take the formula 1 and formula 2 and we will proceed further. So differentiating with respect to x, so what we are getting it as j n dash is equals to summation of r is equals to 0 to infinity minus 1, same way the way we have got it for previous one, n plus 2r divided by r factorial n plus r plus 1 into x by 2 it is raised to n plus 2r minus 1 into 1 upon 2. Now what we are doing, again we are multiplying both the sides by the x term. So what we are getting it as xjn dash is equals to, so summation of r is equals to 0 to infinity minus 1 raised to r. And now here we are doing something different. We call it as, here in this part we are writing here is 2n plus 2r minus n. Okay, so 2n minus n will give me n. Okay, now divided by r factorial n plus r plus 1 into x by 2, x by 2 raised to n plus 2r. Okay, now so which is equals to, what we will be getting it as, so here also we will separate these terms. So it is like summation of r is equals to 0 to infinity minus 1 raised to r. It is 2n plus 2r divided by r factorial n plus r plus 1 into x by 2 n plus 2r minus n. So it is against minus here. So it is summation of r is equals to 0 to infinity. Let me write n here outside, n, and same term minus 1 raised to r divided by r factorial n plus r plus 1 into x by 2 whole n plus 2r. Okay, now if we will check this term is similar to our jn. So what we will substitute this value, so which is equals to summation of r is equals to 0 to infinity minus 1, this term will be as it is, raised to r into raised to r, this term and this term, with this terms we will get something like this, into 2 divided by r factorial n plus r x by 2 raised to n plus 2r, and this term as I told you, the substitution minus r jn. Okay, so further solving this one, so we want x outside for this term. So what I'll do, x summation of r is equals to 0 to infinity minus 1 raised to r so denominator just will be same, r factorial, it will be r factorial. So what I'm doing is, so n plus r is there, so n minus 1, okay, and r plus 1. Okay, so that is plus and minus 1 I'm adding, so it is n minus r and n plus r, and my term same, x by 2. So here it is n plus 2r. So what I am doing is n minus 1 plus 2r. So how we are getting it, minus 1 plus 1, this get cancelled out. Okay, so this I have added here, minus n zn. So as a result, same way, the way we have got it for this expression, so we are getting it as x j n minus 1. So as a result, which is equals to x j n minus 1 minus n j of n. So we have got the formula number 2 for the recurrence relations or recurrence formula. So hence proved. Now let's switch to formula number 3. So formula 3. So formula 3 we are getting it from formula 1 and 2. So rest other all the four formulas we are getting it from the formula number 1 and 2. 1, 2, 3 combined formulas. So now formula number 3, just see how we are getting it. So 2jn dash is equals to jn minus 1 minus of jn plus 1. Okay, so it's just 2 line steps. So what I'll do, see now, x jn dash is equals to n jn minus x jn plus 1. This is equation number 1. This is recurrence formula 1. Next again, x jn dash is equals to minus n jn plus x jn minus 1. This is recurrence formula 2. Okay, what is this? Adding 2 in 1 we get. So what we are getting is 2x jn dash is equals to what is this? Minus x jn plus 1 plus x jn minus 1. So both the sides x values are there. So what I'll do, we'll just cancel out the x term. So we are getting as 2jn dash is equals to jn minus 1 plus jn plus 1. Hence proved. Hence proved formula number 3. Now we'll start with formula 4. 2n jn is equals to x of jn minus 1 plus jn plus 1. So now in this case we will subtract our terms and we will be getting these terms. Okay, so we have again this same thing, we need to write it down, that is x jn dash is equals to n jn minus x jn plus 1. This I will mark it as equation number 1. This is again a recurrence formula number 1. Recurrence formula number 1. Then recurrence, so x jn dash is equals to minus n jn plus x jn minus 1. Number 2, this is recurrence formula number 2. So as I told you, subtracting 2 from 1 we get. So as you can see that this is x jn dash, this is x jn dash. So both those terms will get cancelled out. This term is positive, this term is negative. So we, as I told you, it is 2 from 1. So this will become minus. So we will get this term as is equals to j n jn 2jn minus x jn minus 1 minus x jn plus 1. So minus 1 will be there and this plus 1 will be there. So as a result, this term I will take it to the LHS side. So this will also be minus, but I'll cancel out all the subtracting value, subtraction sign. So 2n jn is equals to x jn minus 1 plus x jn plus 1. So as a result, 2jn is equals to x bracket jn minus 1 plus jn plus 1. Hence proved. Now fifth formula. Fifth. So fifth formula says that d by dx of x raised to minus n into j of n is equals to minus of x raised to minus n j of n plus 1. Okay, so for the sixth formula it will be j of n minus 1. That's it. So these are the two difference which we will be solving it now. So proof. So I'll take formula number 1, recurrence formula number 1. So x of j of n dash is equals to n j n minus x j n plus 1. So what is this? This is a recurrence formula 1. Okay, so multiplying by, so what I am doing, I am multiplying by x raised to minus n minus 1. So what I will obtain is, x raised to minus n j n dash is equals to x of n of x raised to minus n minus 1 j n minus of x raised to minus n j of n plus 1. Okay. So x raised to minus of n j n dash minus n x raised to minus n minus 1 j n, which is equals to minus x raised to minus n j of n plus 1, or else d by dx of x raised to minus n j n is equals to minus of x raised to minus n j of n plus 1. Hence we have got the proof. Similarly, second equation also we will be getting it like this. The last equation, or we call it as the last recurrence formula, recurrence relation, recurrence formula 6. So d by dx of x raised to n j n is equals to x raised to n j n minus 1. So proof, we know that x j n dash is equals to minus n j n plus x raised to j n minus 1. So this is my recurrence formula number 2. So multiply by x raised to n minus 1. So we have x raised to n j of n dash j dash. This minus 1 and this plus 1 gets cancelled out, which is equals to minus n x raised to n minus 1 j of n plus x raised to n j of n minus 1. So as a result, x raised to n j dash n plus x raised to n of x raised to n minus 1 j of n is equals to x raised to n into j of n minus 1, or d by dx of x raised to n j of n equals to x raised to n j of n minus 1. Hence proof. Thus we have derived all the 6 formulas for the recurrence relation. So if you have a look, that we have started with the Bessels function. Bessels function is denoted by j of x. Then recurrence formula, there are 6 types of 6 formulas are there. So this is my first formula for recurrence recurrence formula. This is my second formula. Then my third formula here. Then the fourth formula. This is the fifth formula, and this is the sixth formula. So with this we have completed the recurrence formulas. Thanks for watching.